Good morning and welcome to the Minnesota Stormwater Seminar Series. My name is John Gulliver. I'll introduce the seminar series and then our featured speaker for today. The seminar series is co-sponsored or put on by the Water Resources Center and St. Anthony Falls Laboratory, both of the University of Minnesota. The funding came from the Clean Water Council of the state legislature through the Minnesota Stormwater Research Council. We are really happy and excited to put this kind of thing on. We've had many fantastic speakers, including today. Our speaker today will be Jenn Drake. Jenn is originally from Ottawa, Canada. She did her bachelor's degree at McMaster University and her master's and PhD at Guelph University, the home of the Guelph Permeameter, which you used in your research, right? So I don't know how many of you know about the Guelph Permeameter, but it is well known among people who do infiltration measurements. She has made quite an impact. Well, after that, she went to the University of Toronto. She had hired as a professor at the University of Toronto, where she is in the Department of Civil and Environmental Engineering. She's had quite an impact on Canada in a very short period of time. She was awarded the 2018 Ontario Young Engineer of the Year, and in 2019 she was awarded the Young Engineer of the Year for all of Canada. Jenn does research in green roofs. She does research in, and Toronto has the third most green roofs in North America. So that's a good place to do green roof research. She does research in rain gardens, and she does research on our topic today, permeable pavements. So please join me in welcoming Jenn Drake.
Thank you. Thank you, John. I'm very excited to be here and to talk about some of our recent research looking at operations of permeable pavement for the winter. So I titled the lecture today, What Happens When Permeable Pavements Freeze? Because I'd say this is probably the most common question that I receive whenever I talk about permeable pavements. People are always concerned about freeze-thaw cycle and this idea that if we infiltrate the water into the pavement, surely we're going to be having frost heave and issues like that. And I'm going to just lay it out there so we can move on, that no, we don't have frost heave issues with permeable pavements. The reason for that is these systems, it's a pavement system, so it has open pores, and then the aggregate, it's not your grade A kind of aggregate with fines. It's an open granular aggregate that's washed. So you have a very high void ratio in the base. So even though you're infiltrating water in the winter when the snow and ice melts, there is space for that water to expand when it freezes. So with pavements, we have a number of concerns in the winter. Whether we're talking about a walkway or a parking lot or a low traffic roadway, we're worried about pedestrians slipping on ice or frozen surface water. We're worried about vehicles skidding. And then we're also worried about the pollution that's associated with all of the road salt that we put down every single year. And so there's been a number of anecdotal observations that road salt and the road salting requirements of permeable pavements are quite different from your conventional impervious asphalt or concrete. And so the research that I'm going to talk about today, we were actually trying in a controlled, systematic way to actually look at what are the road salt requirements for permeable pavement. Specifically, we're going to be talking about permeable interlocking concrete pavers, so PICP. So the issues that we encounter in the winter all come down to basically the amount of surface friction that we have. And so in our lab, we have a couple of devices that we can use to measure surface friction. The first one is this called slip test, or the Mark 3B. And it basically simulates a pedestrian walking, and that angle that your foot kind of hits when you're walking, what's happening is if it's slippy, whoop, you fall. So you can see here the little foot, you adjust the angle, and when you get to the right thing, you actually see it slide, and that would be when the person falls. So you can measure then the coefficient of friction. We also have a slip alert, which is by far my favorite toy, and it's just a little car. And so the distance that that vehicle travels is going to be a function of the surface friction. So we're simulating in this scenario a vehicle skidding. So we have these two devices that we can use on our test pad to measure friction under different winter scenarios. Some of you may be familiar with some of these other products. We've tried to work with them in the past. All friction testers are not designed for outdoor applications. They're traditionally meant for testing new types of tile or indoor work environments. So trying to use friction testers outside under snow and ice has been tricky. The British pendulum is a very common one, but we personally just found it much too time consuming to get it set up when you're outside and it's cold. And then we've also played around with a T2Go friction tester, but ran into issues. This is used often in looking at the friction of airport traffic lanes. But if you have snow, we've run into lots of issues with snow accumulating on those rubber tires, which then was affecting our friction measurements. And over the past 2 winters, we've been testing or measuring friction on a test pad north of our city, just about an hour of some permeable pavements. So this is our little research facility. We've got 4 PICP cells that are identical and an asphalt control that's drained by a catch basin. The area that we had constructed this has very clay type soils. So they're all partial infiltration systems. So they each have their own underdrain. And then we have a U-trap so that we could sample and track conductivity and look at water quality. So here's a picture of the test facility. We treated, for this study, each surface with road salt. So 1 cell received road salt at a medium application rate, so 10 pounds per 1,000 square feet. 1 received it at a low amount, so 5 pounds. And then we also did 2 cells where we pre-wetted the road salt with beet juice, which is one of these alternative de-icing products that municipalities are starting to experiment with. And so you can see the main difference here is you can see how that coating, you can see it changes you can see the beet juice sort of stuck to it. It makes it a little bit more tackier. It also changes the temperature at which the road salt is going to be effective at. For the asphalt pavement, we used it at the medium road salt application. So at the site, we had a field camera set up that had infrared, so we were able to take pictures both during the day and night, so we could observe when there was ice and snow and water on the pavement surface. We had surface mounted temperature sensors, so we could look at the pavement temperature, both when it was clear or when it's covered in snow. And then we had conductivity loggers installed where we could track conductivity as an indicator of the road salts or the chloride that's in that discharge water coming out either through the catch basin or through the underdrains from the permeable pavements. So to start off, just so that everyone knows, under dry conditions, the PICP and the asphalt basically have the same amount of surface friction. So just showing here, these are our friction measurements with the 2 devices. This is sort of a recommended minimum level. So dry conditions, you don't have any hazard concerns. There's enough friction. You're not expecting vehicles to be skidding or people to be tripping and falling or slipping. Over the 2 years, we had a number of events where just because of the timing of the snow and the timing of the weather afterwards, it would snow and we wouldn't actually get out there to shovel or apply de-icing. So we were able to observe what happens just without any snow removal or de-icing practices. And so we had 15 of these melt events. And what we would see is consistently melting began and ended sooner on the asphalt. This is more of process due to the different thermal properties. So we're comparing a black asphalt to a gray concrete, not actually anything to do with the fact that that concrete is, or that pavement is permeable. So if we had had black pavers, we would probably be seeing more similar behavior. But the important thing in terms of parking lot safety or operation safety is that 40% of these melt events would still have snow or ice near the catch basin at the end of the day. And that, from an operator's perspective, is our hazard, because that's where someone's going to slip and get injured. And there's a picture of the kind of ice accumulation that we would find sometimes around our catch basin. We also had a flooding event. So last winter, we had a large freezing rain event, and our asphalt cell actually flooded. So because this is not a full-scale parking lot, we weren't below the frost line in terms of our drainage. And so the catch basin and the pipe actually got frozen up entirely with ice. And so that drainage pathway for the surface water wasn't available. And so you can see here in the middle, that is completely full of water. It's spilling off. And you can actually see we still have some patches of dry pavement because water is infiltrating through the PICP. So after this event, the technician and graduate student actually ended up having to install a heat tracer, like a heat cable, so that we wouldn't have that happen again on our asphalt. So we did a series of shoveled snow experiments. So this is trying to simulate a typical parking lot or walkway operation where you would go out, you would shovel or plow first, and then you would apply your road salt. And we collected friction measurements then before salting and immediately after. So we did this in, I think we were able to do a number of 6 different events. And what we observed is that when we would go out and just do the measurement before salting, so we've shoveled, but before applying the road salt, the asphalt would have a higher level of friction, but it would still be below recommended levels. So it was still a slippery surface. And then very soon after the application of road salt, you would see friction levels on the PICP change quite drastically and become more in line with the asphalt, and in some cases also even overpass the friction levels on the asphalt as that water melted and drained. We noticed too, you get different results depending on the systems or the device that we're using here. This is a spot measurement. So we would have, you can notice, much more range and variability, because if your measurement happened to be on a patch of dry pavement or a patch of icy pavement, you either get a very high or very low friction level. Whereas the vehicle is giving us a more overall perspective of the surface. So this pre-salting issue, again, I would argue is more a function of the pavement, not the fact that it's permeable. As you can see in the image here, the asphalt is a poured product, and it has a more rugged surface as opposed to the interlocking pavers, which are of course modules that are quite smooth. So I suspect that had we been working with a different type of permeable pavement that was poured as well, like say pervious concrete or pervious or porous asphalt, we might not see that difference. This is just a fact that we're looking at pavers, comparing them to asphalt, not a function of the fact that they're permeable. We also observed that the salt behaves, or the melting process, or not melting, the dissolving processes that were taking place were quite different on the permeable and impermeable surface. On our PICP, we would also often see full granules of road salt left after the vent. Because the water melts and drains, there isn't that moisture on the surface to fully dissolve the entire granule of salt. In contrast, on the asphalt, where basically everything has to melt and build up so that then it can do overland flow, you would end up with a completely wetted surface, and then a portion of that water ultimately evaporating. And so we would find the salt, you can see the drainage paths here, would precipitate out and then be left as almost like a powdery surface that would even sometimes act as an anti-icing behavior, melting snow the next time it occurred. So what this sort of says to us is that there's probably some opportunity to look at how we customize road salt for permeable pavement applications. Particularly, we're wondering if maybe we move to a finer or a smaller grain size distribution that might allow us to use less salt but still have the same levels of service. Also, if we switch to brine-based products, where we're doing, again, anti-icing or something that's coming in a liquid form, that again may allow us to have the same level of safety with using less material in the first place. In our second winter, we switched from just shoveling to actually doing some ice cover experiments. So it started to occur to us as we were doing the shoveling that, more often than not, when you have a parking lot or a walkway, what actually happens is, someone drives on it or someone walks on it before it gets shoveled, before it gets plowed. And that walking or driving process, the compression melts the snow temporarily, and then it refreezes in a dense ice cover. So what we did is our students went out, didn't shovel, and they just walked on it back and forth, back and forth, back and forth, till we got it all kind of liquidy, and then we left it overnight to refreeze. So we did this a couple of times, and then we went back and put on the salt now that we had like this really thick level of ice. And this is probably the most successful ice experiment that we were able to execute. And it gets really interesting to see how these different surfaces behave. So if we look over here in the corner, you can see here we go again. Before we put down the road salt, they're all very slippery surfaces, not safe surfaces. And then, 20 minutes, this was about 20 minutes after, we haven't seen a huge impact. But as we move further and further away, we start to see friction levels growing as the water or ice is melting and draining. So by the time we got to the end of the day here, you can see that we actually had some of our PIC surfaces, the ones that had the higher, the medium level of road salt, were now above recommended minimum levels. Asphalt is also improving, depending, both scenarios. But when we hit sunset, that's what this blue line is here, asphalt started to lose friction. And what was happening is that there was water that had melted and wetted, but was not able to drain. And when temperatures dropped, once we reached the end of the day, it refroze as black ice. So you can see it here, right? Yeah, you've got bare pavement, but the water here has no way to exit because it can't get over this part that hasn't melted yet to the catch basin, which is mostly blocked with ice as well. With the ice experiments, we also started to see, so first of all, that, yeah, using more salt was giving us better friction and safer conditions, but also using the salt wetted with beet juice, which is the blue triangles, you could see an improvement with the product under this more extreme weather conditions, particularly in our Mark 3B measurements. If we look down here at the bottom, you can also see, so this is the cell with the beet juice pre-wetted one. It has the most bare pavement, and our rock salt low application had the most ice coverage still taking place. So what is this telling us? we'd love to say like, oh, if you have permeable pavements, you don't need to salt. But that's not a realistic reality. What we're seeing is that under mild conditions, you can use reduced salt applications while maintaining the same levels of safety. Under your severe, severe storm events or a freezing rain event, no, you need to use more salt. But you don't need to do that all the time. And so there is opportunity here to reduce the amount of product we have to use over the whole winter if we're smart about it. Here's the picture again, just from this ice event in February. And then this is the black ice that we saw happening at the end of the day. You can see this is the light, it's just around, sunset. So we also attract water quality coming out of this. I just put it in salinity just as a general indicator of the amount of material. What we saw, unfortunately, we weren't able to measure flows. So we can't quite put it to like a mass balance or anything like this. But what we can see is that when we were applying salt in January and February, levels were very high in our asphalt. Whereas we didn't start seeing rise in salinity until we started moving into March from the PICP, when we were getting sustained thaw. And even when we did, we were well down. And just to remind everyone, so I think 30 PSU is what seawater is. So we're halfway to seawater. And this is just, Southern Ontario, pretty much the weakest winters you can almost get in Canada. So where's the salt going? So our conductivity measurements also give us temperature. And so this can help us sort of have a clue in terms of where the discharge is going. If you look at the black lines here, again, when you see these spikes, that's because we're having a flow event. So there's some kind of stormwater runoff that's a new temperature coming through those traps. So we can see both in the winter, these drops of cold water coming in, and then as we move into the spring, discharge coming out. You don't see that same kind of characteristic. And from when we would go out and sample, a lot of the time, we wouldn't see much water in our traps from our PICP. And so what we actually think was happening at this location is a lot of the water was actually draining into those clayey soils. This is not the first time that's happened to us at this property. We go out, we do our infiltration measurements, we can't get any water to drain, and we build our PICP or our pervious concrete or whatever, and there's a lot less water coming out of those drains than we expect. So water is finding a way into the subsurface system. So that is something to think about, because the salt that we are putting down is moving into both the groundwater and the surface water system. I'm not going to debate which is more environmentally harmful. My takeaway is we just need to use less ultimately, because they're one system of ultimately anyways. So it's going to get everywhere. We've also had the opportunity to measure conductivity and chloride from an operational permeable pavement parking lot. So I'm going to switch to this site just so we can look at this data as well. So this is a demo parking lot in the city of St. Catharines, which is about 20 minutes from Niagara Falls. It's in wine country in Ontario. An hour and a half if there was nobody on the freeway from Toronto. And they built a porous asphalt, pervious concrete, PICP, and then an asphalt control. It's their where they keep their fleet and also like their engineering staff. So the nice thing about, I'll just switch back for a second. Nice thing about this location, these were all set up as a zero exfiltration system because they were concerned about the stormwater and infiltrating. So they actually put membranes at the base, and then each of the pavements has its own drain and its own monitoring sort of manhole, so you can look at the discharge in isolation. So over about 2 years, we did a number of samplings, so we were able to develop very nice conductivity chloride relationships. And so we were able to actually calculate chloride from our continuous conductivity data. So what we saw, I'm going to start in the fall of 2016. So this was when we would see from the PICP probably the lowest chloride levels. You'll note that they're actually above the chronic exposure levels, the EPA's chronic exposure levels. So they have higher concentrations coming out in the summer and in the fall. But as we move into the winter season, the blue is the runoff from the asphalt from an impervious parking lot, and all the other colors down here. So you do see these, you do see elevated discharge, but we're talking orders of magnitude smaller. Now this is a zero exfiltration system, so there's no actual removal of chloride ultimately taking place. Chloride is going to move through. It's moving through the system though in very different pattern behavior than it is on the asphalt. It's being detained and attenuated. And so what we're doing is we're eliminating these, extremely high discharge shocks that are taking place in the winter and replacing it with higher levels in other times of the year. So the next question for us as researchers is this a good thing? I'm not sure yet. But potentially it is. Winter's a low flow time of year. Species of risk might be at more not as able to deal with this sort of exposure, and perhaps using the same material but releasing it at a different time of this year may mitigate some of the negative implications. There's certainly something we need to look at more closely. Just sort of wrap up the year, we can see into the spring. Again, as we move away from that winter, the levels in the asphalt come back down more in line. And in fact, towards the end, we actually did finally drop below the chronic level in some of our asphalts. But it certainly is interesting. So kind of takeaway, what have we learned from these past few years of trying to look at permeable pavements in the winter? So number one, if they're dry, they are both going to give you an equivalent level of safety from a pedestrian or a vehicle's perspective. Shoveled snow followed by de-icing. The PICP surfaces have a lower surface friction than the asphalt. But when both treated with a medium level of road salt, they provide similar levels of safety soon after the snow begins to melt. And this difference in surface friction is more a product of their thermal properties, not impermeable versus permeable. The PICP treated with the reduced road salt provided similar friction levels as the PICP treated with the medium level. So demonstrating that we can reduce our road salt use rates without sacrificing safety. And under these conditions, the addition of the beet juice did not provide any additional benefit. De-icing under icy conditions. First of all, we didn't see a difference they were both very slippery because they were both covered in ice. So it doesn't matter what surface is beneath, it's ice. People are going to slip. The melting and drying occurred more rapidly on the PICP surfaces with the medium application rates and when pre-wetted with beet juice. Refreezing of melted snow and ice was an issue observed on the asphalt, creating black ice conditions. And under undisturbed snow events, the melting process occurs, again, driven by thermal properties, color on the asphalt. Despite this, we would still often see meltwater that could potentially refreeze as black ice at the end of the day. For water quality, the measurements are demonstrating that permeable pavements attenuate and buffer the release of de-icing salts. They do not, though, provide permanent removal. So the road salt is going to ultimately leave that system either in the underdrain or into the native soils. So our only reliable way to reduce chloride is to minimize the use of it in the first place. So what's next? As I sort of alluded to earlier, I think there's real opportunity for us to start looking at anti-icing practices, particularly on permeable pavements. So we'll see. I'd love to be doing this in another year or two. I'd like to give special thanks to the graduate students here that did all this work. And also would like to acknowledge none of this would have been possible without financial support from NSERC and the ICBI Foundation. TRCA provides their property that allow us to go and do the research. They also provide us with a lot of technical support. Materials were provided by Oaks and Lafarge, and then we had a couple other graduate students that helped out, you know, in the winter. This is hard work, people. I'm so fortunate to have such a great team of graduate students. Oh, I don't have a thank you page. So thank you.
So what sort of questions do you have for Jenn Drake? Hang on.
You were questioning maybe we should use finer pellets of material. What if you went the opposite way and you had pellets left over? Did you see the pellets there and active during the next storm?
They were, but our perception is they were almost too big, right? Because that granule has to get coated in water to dissolve, right? And because the water isn't ponding at the surface, it's not getting wetted enough. So my biggest takeaway is I want to look at this a little bit more, because I don't know, like, what's the right product, or how can we make these products more reactive while also reducing the total amount we need to use.
Yeah, because some of it is also the labor to put it on. So
yeah.
If in fact you had bigger particles and they were still there but didn't dissolve, that would provide the same benefit.
Yeah.
So we have, are you familiar with TMDLs?
Yes.
In the United States? So we have a chloride TMDL that now is going to impact a number of regulated cities. What I'm wondering is, do you think that installing more pervious paving should be part of the strategy, or one of the strategies, to address the load reduction under the TMDL? And is there enough information in your research to provide a quantification in terms of an estimated load reduction, even if it's just approximate and stays on the conservative side?
I think optimistically that yes, you probably can, because what we have been able to show is under, shoveled followed by application, we were able to have it, and we still had the same friction levels. So that, that's your everyday small storm event situation. When you have a big winter event, you still got to use higher amounts. Nobody's saying, like, don't put down more salt when you have freezing rain, but there is definitely, the data is there, and repeated data that you can reduce it and still get the same levels of friction. And I think, especially if we then move to anti-icing and brine-based materials, there's an even greater opportunity to really reduce the amount of salt that's needed, because the hazard is it's that black ice, and that's what we were able to eliminate over the 2 years.
Okay, we have a question from online.
observed increase in friction following salt application can be attributed to the presence of a granular product sitting on the surface compared to the effect of the salt actually exposing the pavement underneath of it?
Oh, that's a good question. Depends on which measurement you were looking at, right? So in both cases, sometimes they would be affected by the fact that there's now a bump that it might go over. We found with the Mark 3B, that would be more affected because we'd actually observe if you had a spot where you had a granular, the foot would actually crush it. So you could actually see that crushing taking place, which then gives you a high measurement value. The vehicle, my sense, is less affected because it's a longer area that you're looking at. So that point variable is kind of washed out by all the other areas of surface that don't have the particle.
You have a question, Jay, still?
I do. Thanks, John. Just one observation, and I've been spending a lot of time in Toronto, but we seem to have an entirely different approach at salting than you do in Toronto. And number one, the size of the rock salt, as we would call it, and the amount that is put on is, in my mind, phenomenal.
Toronto?
Yeah, I mean, in comparison, where we're using more of the ice melt kind of finer salt tablets. I'm kind of thinking that just getting the size of that material to start breaking down and moving around might have some effect on that. Do you think a finer material going in and the experiment with a finer material would have different results?
I do. I absolutely think that changing the grain size will affect the rate of melting that occurs. And so that's sort of, it's on my top list of like the next things that we need to look at is how do these pavers, those permeable pavers behave when you have same total application rates, but different particle characteristics or material characteristics. Yeah.
In situations where you have appreciable clay below the permeable pavement, would you expect the sodium to have some effects on the performance of that clay dispersal and so forth?
Yeah, that is a difficult question to answer. There have been some studies that have started to see sort of like ion exchanges in the material underneath. And then there's been other studies that haven't, you know, they've gone in and they've sort of like cored out and sampled. So I think that's an area that we're not sure. And it probably has to do a lot also just how much water and what's in the water that's being applied and draining into those soils. And it's different at each location you go to.
Jen, going back to the parking lot study, if I understood it right, the chloride had different melt patterns based off pavement type, at different ways it behaved throughout the season or through the year. Do you think that presents an opportunity for management strategies by parking lot based off type of construction for chloride?
Yes. Like, do you mean like if you have concrete versus asphalt? Yes. Or I think the other thing is, what if you have dark colored concrete? Because a lot of the we actually, for better or for worse, when we were planning the experimental design, we debated which paver to use a lot. And we on purpose went with the gray ones because we thought that's what is most common at the moment. Like that's the products that we see in our area, and we didn't want to get accused of like really like stacking the odds in our favor by purposely, you know, just building a black concrete. But I think the tricky thing too is what is your environmental objective? Because if you move to a dark pavement, that's great in the winter. It's going to melt. You're going to need to use less salt. But what about urban heat island in the summer? So what we really need is a concrete that changes color with temperature. So my next job is I'm going to talk to the guys down in concrete and say, like, that product exists. I have a 1-year-old. I have a spoon that changes color if it's too hot and it goes white. How do we do that with concrete? Because that's what we would ultimately would get us both summer and winter, benefits.
We have a question from online.
To experience any difference in the degradation of the porous and traditional products from the application of the salt?
No, and I think it's important to note here that we are looking at PICP, right? So the PICP they are solid concrete. There's not that much difference in terms of an impermeable interlocking and a permeable interlocking. The difference is just the joints widths and what's in the joints. So you don't, if we were looking at pervious concrete, I would have expected, or that maybe you would see more degradation with the higher salt rates. But this is a concrete paver. We use them all the time, and they weather our winters fine. We know how to make solid concrete that's going to work in winter.
Another question, yes, in back.
So this is kind of related to the previous question, but I was curious if you had an idea, especially in the parking lot, the study of kind of the baseline ability of the permeable pavements to infiltrate water during the warm season, and if and if that degrades over time. I think there's probably several people here from the cities, especially, who have found that some of their pilot studies don't work as well after maybe 7 years or so. And
so I didn't talk about it today, but in parallel to this, we actually did a maintenance study on PICP, testing different equipment options or mechanistic approaches, including pave tech and power washing and regenerative air sweepers, vacuum sweepers. So if anyone's interested in that, please follow up with me afterwards, and I'll share materials. We've been looking at how you maintain the surface, particularly with PICP once you encounter clogging. In my experience with pervious concrete, it has a very long effective life because there's such a high void ratio that you easily can get 10, 15 years of before you're going to require maintenance. And then in that situation, the maintenance is often being driven more of structural issues, not failing the water quality objectives. Yeah, hopefully that answers your question.
yeah, and then is there a lot of sand or grit used for traction in winter, or does that present another water quality?
Yeah, so we would, for a permeable system, I would absolutely never put sand on it. That is a bad operational practice, and you will lose your surface infiltration very quickly because the sand will accumulate and block the passages. One option that you can do, particularly with PICP, if you want something that's going to be grit, is use the same material that's in the joints. Right, so it's a chip stone often, or some kind of high performance bedding. You can use that as a material for traction in the winter, and it's not going to clog the pavement because it's the same size. It doesn't have the fines in it. Yeah.
Another question from online.
Flush of sediments as a result of changing sodium absorption ratios during the spring melt from your unlined clay system? How long did this occur for if you were observing it? And were you doing any monitoring for turbidity?
No, we were not monitoring for turbidity, and we did not see anything like that. But I would also just sort of put big caveat that we only have one season of observations, and we were in the process of finishing, so we weren't really looking for that. And we did not observe a lot of discharge period from this test cell, and they're very small too, so that meant there wasn't a lot of water to measure or collect, because we're talking a 2x2 meter pad with no run on, so it's only what rainfall falls on that can we track, and a bunch of it was disappearing into the ground. Yes.
How about the catch basins in the commercial one that you had? Did you do any evaluation of the water coming out of those 5 different applications?
Not all 5. We did do we did a 6-month monitoring project a couple of years back just on one of the cells and the asphalt. And you can see beautiful difference in terms of the first flush. Just really turbid water coming off of the asphalt and much cleaner water coming out of the drains from the permeable.
You had mentioned in your slide that you'd put thermocouples on the surface. Did you put any thermocouples below ground?
No.
I'd be curious as to what the temperatures are.
I would be. I know. I would be curious. I'd like to do that too. In fact, the temperature sensor thing was something I added quite late in the game. We ended up going with the types of sensors you normally put on solar panels, and it worked really well because you just sort of stick them on, and you have the little reflective tape and everything, and gave us some nice temperature data. But we didn't have. We should have. It would been nice to have some thermometers down further below.
So this is a bit off topic, but you do a lot of work on pervious pavement, so it's worth a shot. With porous paving systems, the assumption is always you get infiltration and you get storage. But generally from the porous pavement system and the underlying rock, the thought has generally been you get minimal water quality improvement. But years ago, so I saw a presentation by John Sansaloni from Florida, where he looked at water quality improvement from biofilm that developed on the rock underneath the system. And he was finding significant water quality improvement as the water moved through the rock. You seeing anything similar?
I think that's a big area that's still not very well understood, is what's happening in terms of biological or potential biological processes in the subsurface. I certainly would say anything that's associated with the suspended particulates, you're going to see water quality removal. So your TSS, particulate bound nutrients, particulate bound metals are actually going to get captured. We've also observed in the winter, where we knew we had some saturated conditions, some denitrification taking place just in the spring when there was, during the melt, and you could actually see yes, there was some saturated conditions temporarily. And in a year's time, I'm going to actually start experimenting with a permanent wet zone. And pavement engineers are going to hate me, but we're doing it on a walkway, so there's no vehicles, so we don't need the structure. But again, with stormwater, I always think what is your system, right? You can get different surfaces at different locations in your property. You want a treatment train. You don't want to. You don't have to do everything at the same spot. But when it comes to the biological processes, there's a big question there.
One more question from online.
Field scale monitoring site, were there any differences in the salt application rates or in the type of maintenance that was done between the different test areas?
So the operational parking lot? Yeah, so no. Basically, when we first went there, the city engineer swore that his permeable pavements were not salted. Really? And sure enough, yes, their city crews were basically, they would just do they would plow, push it over to the ends, and then they would just go over with their trucks. I mean, this is where they kept all their salt in their fleets anyways, so just on the way out, they just drive over. We really tried to actually quantify how much was going on unsuccessfully. They have a GPS tracking system because of smart unsafe, and it actually only starts working once they leave the property. And it was just like, no. So we weren't able, but more or less they were all receiving the same amount, and they hadn't received any maintenance, like permeable pavement, like cleaning or any sort of maintenance when we were collecting data. They were just, and that parking lot is filled 24/7 because it's their crew. So they actually have a day staff and a night staff that comes in. So there's vehicles on that parking lot 24 hours a day, you know, except for holidays.
So I'll give myself the last question. In Minnesota, we're all familiar with black ice. And black ice is really the part that scares you because you can't see it. If you're driving, you can't see it. I have seen accidents right next to me on black ice where people were speeding up and spinning out, and people have slipped on black ice. So I think the fact that you don't have black ice with permeable pavement is a pretty big deal.
I think so too.
And I'm not so sure that it's that important to get rid of the snow, you know, to remove all the snow. I think we could slow down a little bit. And my question is, do you have any perspective on the black ice versus snow potential for slippage?
No. Yeah, that's a really good question in terms of which is going to be more dangerous. And yeah, what we were doing in this study is when we shoveled, we were left with a very small, like, dusting layer in most cases, and the joints would have snow in them, and sort of like the divots on the asphalt would have snow in it, but very limited amount. And we didn't actually do any measurements when you still had a deeper coverage, and part of that is because from previous times when we have getting these friction measurements to work once you have snow, I'm not very confident in the results because, like, that foot, it melts it. So it's, what are you actually measuring? So it's certainly another area that we need to look at to fill in this really dry, small snow level to, like, covered in ice in between where you have some snow coverage. What is that for the vehicles? What is that for the people in terms of friction? I don't know. Yeah.
All right, thank you. So we'll close this with, and then we'll start, I guess, in about 5 minutes with the panel discussion. Let's please thank Jenn for her talk.
Thank you.
Very good. Welcome back. We are now going to start our panel discussion. My name is Andy Erickson. I'll be operating as the moderator for the panel. I will start first by introducing our panelists, asking how they relate to this topic of permeable pavement in cold climates, and then we will open it up for questions. So please have your questions ready. To start, though, I'd like to introduce our first panelist on the far side, your left, my right, Tom Wesolowski, who is the city engineer at the city of Shoreview. Tom, how do you relate to this topic?
Well, we actually installed our first permeable concrete roadway in 2009. So we've been, experiencing plenty of Minnesota weathers with that over the years. And then we've also installed permeable paver block in a couple of residential areas as well. First one in 2014, and then we did subsequent ones in 16 and 19, and we have a project scheduled in 2020 to install some more. So we're kind of all in with permeable pavers and concrete, and so we have a big interest in dealing with ice and what's best, and is salt something we should be using or not. So it's a good information to learn. So
great, thanks, Tom. Our next panelist is Bernard Izevbekhai, who is a research operations engineer at MnDOT. Bernard, how do you relate to this topic?
There was an initiative in 2006. We were approached by the Aggregate Ready Mix Association of Minnesota, and they wanted us to look into pervious pavements. At this point in time, we looked more into the mix design, particularly in view of the Minnesota weather. So we couldn't lift a lot of information from Florida, where they had some initiatives, but we had to look into our mix designs, and we built a plethora of test cells, starting with just an initial driveway. And ultimately, we built and instrumented with, we instrumented some sidewalks. And later we built the actual test cells on the main road, low volume road. And this was funded by the local roads research board. And I happen to be the principal investigator of that study. Parallel study was done with asphalt test cells. And the instrumentations we used were the thermocouple trees and the water blocks up to 12 feet below the surface. We were able to see the freeze-thaw cycles, as well as the, not just the freeze-thaw cycle, but the temperatures as well for the various layers. And we were able to observe the geothermal advantage of using pervious pavements. So we did a lot of monitoring with friction, with skid resistance, that's using the lock wheel skid steer, as well as the dynamic friction tester. And we brought the deep tester also from Federal Highway to monitor these test cells as well. But one area where we excelled was the introduction of acoustic measurements to pervious pavement. That's the greatest proxy we found out for the condition of your pervious pavement. When we use acoustic impedance and measure sound absorption, we see beyond the sound absorption. We're able to observe, and we did that extensively on the Shoreview test cell, Shoreview streets, because we monitored that for them and rendered a 7-year construction report. The final thing I did very recently was in the International Low Volume Road Conference. We kind of brought everything together, including the boat landing at City of Detroit Lake, which is another successful initiative. That was a deployment of our pervious pavement research. We brought everything together in the nuggets that we observed from our research, and that's published by the Transportation Research Board of the National Academies. It actually catalogs all the initiatives and the deployments we have done in Minnesota on pervious pavements.
Great, thank you, Bernard. Our next panelist is Ryan Johnson, who's an environmental specialist at the city of Roseville here in Minnesota. Ryan, how do you relate to this topic?
Thanks for having me. I am very excited to be here. For the city of Roseville, I've been here about 6 years. I focus on stormwater. I focus on water quality. So for the porous pavements, we've added a few in the city. We have a couple in Falcon Heights. We really like to utilize them kind of in the best fit scenario. So I really like, incorporating them in so we can, get some water quality, get a lot of drainage issues taken care of, take care of some rate issues. So yeah, it's like we like to incorporate them as we can. I also am really interested in kind of the water quality component that Ms. Drake talked about. And so yeah, it's like we use it, stormwater. I don't deal a lot like with the salting of the roads. I do deal with the TMDL components of it. So again, it's looking at how we can potentially increase the number of these we put in the city, and then what we could actually do like with our chloride reductions and how this could all fit together is fascinating.
Great, thank you, Ryan. Jen gave us her relation to the topic. We had a lot of really great questions. I'd like to continue that momentum and jump right into questions from the audience. If you have questions here in the audience or online, please submit them and we will start asking our panelists. Who has a question first? Please.
The discussion earlier came up to salt and the impact on the surface of the pavers. And even though it is a masonry product, I'm seeing a number of applications that are now going on 12 to 15 years old, some of our earlier ones, that we're seeing the surface deteriorating, much along the same way as modular block walls had issues way back when. Tom, you've probably got more experience in this than anybody in the game. What are your observations from Shoreview over the last, or from your older pavements?
Thanks. Yeah. The permeable concrete is where we're seeing some surface spalling. It's been in for almost 10 years, so it's obviously our oldest pavement. But unfortunately, we had a typical winter the year after we put it in, where we had that December rain event that went to then sub-zero temperatures the next day, and we ended up with ice all over it. And unfortunately, we did have to put some salt on more of the curved areas of the roadway. We have a couple curves in there. And we've had to do that subsequently over the last couple of years. And so we have noticed in those areas particularly that we are seeing some surface spalling. And then one section of the roadway ties into a Ramsey County highway, which they salt fairly regularly. And we've kind of noticed the first 50, 60 feet of that is also experiencing the same thing. I think it's just people bringing snow in, stuff like that. So what we've kind of learned from that is I think as an engineer, you have a tendency to want everything to look nice and uniform and, put permeable concrete everywhere. But, in retrospect, what would have been best is in the curved areas or that area coming out of the roadway, like a regular concrete or an asphalt would have been a better solution there. Still would have had the benefit of the concrete all over, the permeable concrete in the other areas, just without that problem. As far as the paver blocks that we're using, the oldest installation we have was 2014, so that's about 5 years. We haven't noticed anything yet, but again, it's not that old. But we have gotten in the practice of sealing those. So we did seal it right after we installed it. And then I don't believe we've sealed it again, but we're talking about coming in and doing that again here, probably the year 5. So I think that would be the key as well, is coming in and making sure you've got that sealant on there. And I guess we'll see with time if that does make a difference.
Just like regular concrete or regular asphalt, there are 3 enemies of pavements. Number 1 is water. Number 2 is water. Number 3 is water. In the case of pervious pavements, we actually want the water to flow through and not sit there, particularly if that water carries certain deleterious materials like de-icers. In our experiments at Main Road, we stayed away from de-icers because like we observed, the freestyle circles are different. They're pretty different because there's a geothermal balance. So we did not really need so much ice activity, we noticed, snow and ice activities, in sand. And in fact, during the construction of the pervious pavement, rather than the alpha-methyl styrene curing compound, which we would typically use on the surface, we stayed away from that and we used a biodegradable material, some linseed oil type material instead of the alpha-methyl styrene. So generally, we did observe the portion that the city engineer talked about at Shoreview, where there was some ice activities because we asked what may have happened there. There was some evidence of some influence of previous pavements are all surface. Even in the matrix, everything is surface. So we would imagine what will happen to a surface and probably some steroids when the icers are applied. So we deliberately stayed away from de-icing chemicals because in itself, if the voids are communicating and if the system is pervious and conducting the water through or not allowing it to stay there and the ice lenses to build up, definitely will minimize the deleterious effect of the icers. First of all, by staying away from them, absolutely.
Other comments or responses to the question?
Just one other one. It's the city of Falcon Heights. We put in a porous parking lot in about 2011 or 12. And again, kind of like what Tom mentioned, is where it's adjacent to a county road that does receive a lot of salt. The parking lot doesn't get, it gets minimal, just basically to make a safe surface. And, we've seen a little bit of breaking up a little bit closer to Larpenter. And as we moved up, the surface started to kind of go back to the way we thought. The only random thing that we ended up coming across in that parking lot is it actually compressed a little bit more as you got more towards the typical pavement. So there's a little bit of an area that just kind of sunk. So we can't really explain that yet, but it was the only issue that we have is a little bit of salt issue on the south side, and on the north is, just a little bit of slumping. After all these years.
Interesting. What other questions do we have for our panelists or our speaker? we have other questions online? Please.
Yeah, there's some questions online regarding the costs of the permeable systems versus your traditional systems, both in terms of the upfront construction costs, ongoing maintenance costs, and if there might be any savings from reduced salt application or other type of maintenance activities that would yield some savings over the life cycle of the pervious product.
I thought Tom was going to start with that. Sure. Because we actually analyzed the Shoreview initiative to do a cost benefit analysis. And what we found at the beginning of construction, just the initial cost, just like everything, every initiative will be costly at the beginning until it becomes commonplace, until it becomes popular. Then the cost evens out. Now, what we observed when we built the driveway at Main Road was that it cost us about 1.3 times what it would have cost to do regular pavement. I'm not including the instrumentation. Typically, ours is a unique case because our instrumentation does cost more than the pavement itself. But in city of Shoreview, they decided to do pervious pavement because when they did an initial cost analysis, not even a benefit cost analysis spread over the service year or the number of years of service and discounted to the first year, they found the pervious pavement to be cost beneficial. The initial cost was cost beneficial compared to an asphalt pavement with the hydraulic structures. So here they were saving in the hydraulic structures. That's the reason why they went ahead. Now, when we did a 7-year analysis for them, what we did was we now looked at, we discounted everything over the years, and then we created a scenario of vacuuming twice a year as your maintenance cost. Then we said that at the 9th year, you probably want to do some diamond grinding. Now, diamond grinding is an effective way of doing a solid maintenance after a good number of service years in your pervious concrete. Because we did that at Main Road too. We did, and I have a paper, a published paper on that, on the effect of diamond grinding on pervious pavement. Diamond grind actually has a very strong vacuuming effect so that the slurry that's created during the grinding is completely removed. So that fear that will, in the process, counterproductively clog the pavement does not exist when you diamond grind. And then you restore the surface and everything works very well. So we found a huge cost benefit in the pervious pavement when we applied it over a 15-year period using the analysis. And that's in the report, the 7-year construction report that we did for the city of Shoreview.
City of Roseville, it ended up being about 30 to 50% more to install our porous over just typical. Most of the time, if we're going in and we're doing something porous at the same time, we want to also solve some kind of a stormwater issue. The one that was 50% the cost or 100 twice the cost it's supposed to be. We were actually, the big benefit of going in there and doing it porous was it was a tight corridor. We had big drainage issues. We flooded homes through this area. We really had, we didn't have any right of way. So we, saw the extra cost as actually a benefit that we could put something in. It would solve kind of a gravel road issue and to take care of the drainage, take care of the flooding. So the additional cost for us, ended up being, while it was double the cost, in the end, it was, a wash for us at that point because, we protected somebody's home, helping improve some of the water going to the lake. I got rid of taking a bunch of phone calls every time it rained, which is priceless. And yeah, so it actually works out well, even with the additional cost for us.
Yeah, just to add, we kind of looking at the same thing in all the areas where we've installed permeable pavements. They're well-established neighborhoods. We're coming in, we're reconstructing, and so we don't have any other areas to put surface type treatment, things of that nature. But, you know, there's also the kind of the character of the neighborhood that you're kind of looking at. And so in these instances, you're not digging deeply to put in subsurface type structures. And they're all adjacent to lakes. And so again, you got a high quality water body sitting there. In the instance of where we put the pervious concrete in, we were able to not have to put in a outlet to the lake. So we eliminated a direct discharge there. So again, like Ryan mentioned, there's other benefits kind of beyond cost that you look at when you're looking at these, and we felt that those were important. And as Bernard mentioned too, then you're also doing away with all the stormwater infrastructure that you typically put in, catch basins and any of the piping and the maintenance and stuff that goes along with that. And so when you look at all that and you look at a you know, total cost, I think we're still kind of determining, you know, whether or not, you know, cost to cost even over time if it's equal. But again, we still just feel the benefits are there regardless if there's some larger upfront cost.
Yeah, I would just sort of reiterate the same sort of thing. I think in Ontario, most of the experiences is you're comparing a paving system, but now paving plus drainage management or water quality management. So it's an apples to orange cost comparison. And even on the operation and maintenance life cycle, we have chronic issues of even our regular pavements aren't being maintained the way they're supposed to be. You know, asphalt's supposed to be resealed pretty frequently. And if you actually look at what best practices are, it's comparable. Or even if you have a curb and gutter, you got to clean out those catch basins every year. So you are just substituting one operational practice, and it's more of the fact that it's new that's driving up the cost. That becomes more common and prevalent. You know, economies of scale will apply.
And I kind of want to dive in a little bit more on that, because that's exactly the point. If we have a conventional pavement that has its own maintenance, but then we have a separate storm sewer treatment system with its maintenance, and we're now combining this system into a permeable pavement system where it's 2-in-1. You know, I'm really interested in that. How would that service life of a conventional pavement with its maintenance plus treatment practices and their maintenance compare to maybe a permeable pavement system that replaces all of that? Do you have any sense, based on the years we've had these in place and the maintenance we're doing on the permeable pavements, how that might compare? How does that wash out?
You know, I can say that our maintenance department actually really likes the permeable pavements. Probably more so the paver block than maybe the permeable concrete, and that's mainly because it's easier to clean. We have a regenerative air system that we use, but with the permeable paver block, you have you know, more of you have a solid surface, and then you have a fairly large gap, 1/4 inch or something, and then that is just easier for them to clean. Or if for some reason there is an event where we do get a fair amount of material in there, you know, power washing is again fairly easy. Permeable concrete's a little harder. You have smaller pores, but again, if you maintain it, which means sweeping, you know, at least twice a year, and in some of these areas we do it more often, because we found that organic material is actually more of an issue than sediment. Again, these are established areas with a lot of trees, so you have you know, pine cones and pine needles and leaves and stuff. So during the time of year when we do have a lot of that falling, you know, in September, October, we're actually probably down there in some cases every 2 weeks just to get that material up. It just saves time in the end. You know, and then so, you know, for us, we have a regenerative air that we're using throughout the city because it picks up fine particles better than a regular sweeper. So we're already running it around. Now we're just kind of coming down to this area maybe a little more often. Where when it comes to the other types of infrastructures, Ryan and I were just talking about this before, you know, if you have a subsurface infiltration area or treatment area, that means you have a sump. You know, we're now getting to the point where we're having, you know, 100+ sumps in our cities. And that takes time and effort. Twice a year, you got to run out with a vac truck, and that's a $300,000 piece of equipment. And as Ryan and I were talking, our street and utility or stormwater department and our sanitary department are fighting over, you know, the same piece of equipment, which is, you know, something that I think most cities are struggling with. So again, it's a balance. And You know, if our guys don't have to go out and try to borrow the vac truck to go out and do the pits, and they're already using a piece of equipment that they're used to, they have, and it works well, to them, it's a benefit. So.
Just wanted to add that from a MnDOT perspective, the previous pavements that we built, they are geared more towards local usage. They are not a replacement for our 60-year design in the network, which is the high-performance concrete or the high-performance asphalt pavement in the network, in the freeways. That's not what we want to compare them to. We're comparing them to parking lots, local streets, and probably rest areas if we want to place them close to our freeway system. So on those bases, then we can do benefit cost analysis. We can look at the years at which we have effective service. And previous payments are very low maintenance. If the initial design has been done, this is what we observed after our years of study. By the way, the test cells at Main Road were removed only because we needed to do further studies on some other initiatives, not because they were completely unusable. We had the pervious overlay. We had the full depth pervious asphalt, full depth pervious concrete. We had granular base that was a partial detention stroke storage over granular subgrade, and that performed much better than the one that was over a clay subgrade. We had an aquiclude at about 30 feet, 2 feet below the surface, and it kind of sloped downward, so that was a good area to put contiguous pervious asphalt and pervious concrete on clay subgrade and granular subgrade. Enable us to do the study. But the point is that we have done the analysis and we have found out that in a low volume situation, because of the low periodic maintenance of pervious pavement, and if diamond grinding is done for pervious concrete at about the 10th year, it can give you a benefit cost greater than 1. In a low volume usage. Yeah.
We haven't seen anything different. Most of ours are in, again, kind of tight corridors. So we're going out and doing a lot of maintenance anyway, just with, like Tom mentioned, just additional sweeping, trying to keep the organics off. The one component that we've kind of liked with the porous block that we have is we had a small break underneath. And basically, it's like we could go in there, we could take the blocks out, we could take some of the rock out, we could do a repair, and we put the rock back in and the paver back on top. So that was one reason that we kind of went to the paver block versus, you know, having an asphalt or a concrete where we'd obviously have to go out there, we'd have to cut that out. We'd have, you know, how do we find, you know, 20 square foot patch of porous asphalt? I don't know. Otherwise we have to put in typical, and you look at that, and then, you know, I'm a visual guy. I can't go out there and see that. So then we'd have these additional seams. So that was just one other component that we really liked from just the porous block side, is getting underneath it was actually really easy and made, you know, something that could have been a little bit more difficult easier for us in the long run.
Yeah, I would say at least up my way, Permeable is almost entirely PICP. We haven't had any movement on porous asphalt in a decade, and very limited installations of pervious concrete. And a lot of it has to do with the ease of maintenance once it's installed.
What other questions do we have for our panelists?
Question on the milling of the concrete.
Yes.
How thick did you mill down with the diamond?
Oh, a typical diamond grinding, the conventional diamond grind goes to about 1/4 of an inch. And mind you, that's 1/4 of an inch in the surface where you are imparting just the configuration. It removes scallops. The main reason why we did the diamond grinding was that based on the way it was paved. It wasn't slip form paved. It was paved with some screed. So the screed imparted some waveforms on the surface. Those scallops needed to be removed because it caused very poor ride, poor pavement smoothness, or the ride was bad because of that. So generally what we were doing was removing those scallops. Those scallops in some places were like 2 inches, okay? Yeah, so we removed those scallops and we were able to now impart the diamond grinding configuration. So the configuration it's about quarter. When it goes very deep, about a quarter of an inch. Most of the time it's 1/8 of an inch. They're usually set to the more hardness of the basic aggregate in the matrix.
Other questions for our panelists or our speaker? Right here.
So just getting back to a little bit more of the functionality of the permeable pavement as a best management practice in cold climates. So is it a better technique in cold climate because, as some of the research showed, you can do sweeping and de-icing and allow that surface to infiltrate versus, say, a biofiltration basin or something vegetated in a cold climate, which is dormant during the winter months? So what are the thoughts on the utility or benefit of permeable surfaces in cold climates versus other types of BMPs that might be vegetated?
I would say you should do everything. I mean, really, I think this is what we want, is we want a suite of options. Permeable pavements are a great option for putting things in the road right away, but having vegetated and living infrastructure is also something I don't think we want to, I would never say like, oh, only permeable pavement, there's no value in these other ones. They provide additional other services, and there may be situations where it's a more appropriate solution as well. So I really think, you know, cities in cold climates need to be looking for redevelopment opportunities and solutions that fit the community they're focusing on. And sometimes that's going to be a green roof, sometimes that's going to be infiltration trench, sometimes that might be permeable pavement, or sometimes it might be a rain garden. We don't want to like eliminate, you know, any of any tool from our toolbox.
Yeah, I would agree. I mean, I think that's the way we look at it now, is that, you know, since we put that first one in 2009, we've done 10 years of reconstruction projects, and we've done everything from underground infiltration to more pervious pavement to more of the biofiltration type. We put underground filtration systems in. So we've kind of done it all. It just depends on what seems to fit the best. One thing I just would like to mention, because if you're talking about functionality, and what we're seeing in the field is exactly what the test results are showing, that Jen is seeing there, is that, you know, on an asphalt street, you do get that thermal property and you get that melting right away, where the permeable pavements, when the sun does come out on a nice day, you know, if we get a nice couple 30-degree days, you will see the melting, and it may take a little longer, may take a day or two, because not only on the surface, but I think it kind of maybe has to get down and maybe get the rock, you know, moving to the water through the rock. But what we're seeing again is exactly what they're seeing, which is the asphalt freezes, and of course things move. You get dips. It doesn't get to the catch basin. It sits in the curb and gutter, and then it refreezes at night. Where within 2 days, our pervious pavements are dry. And so when we have thaws during the middle of the winter, you'll be driving around and our pervious pavements are perfectly clear, and there's ice all over asphalt. In the spring, that's where we really see it, because it can take up to a couple weeks, I think most of us see, before a lot of our streets are really draining down. And again, that's the thing with permeable concrete or pavements. Again, the snow is melting on the side of the street, and once the street's clear, all that water is going down, and it's going down right away, not against the gutters. So that is a big benefit that we do see, is that those streets are fairly clean, in some cases weeks before the asphalt is dry.
Yeah, and when we start looking at porous pavements versus like the biofiltration. The way I ended up kind of looking at it is, we're basically taking that water, whether we're infiltrating it through the, the material on the surface of the street, or if we're basically catching in a catch basin and it goes to the biofiltration. The biofiltration, slowly works over the winter too. We're also, at least I'm not looking at it as we're trying to capture this huge volume of water in the winter. We're trying to capture that big volume in the summer when we get the big rains. And again, yeah, this is one tool that we use. So, I'd love to be able to do porous all over the place, be able to free up some other areas. But, it's like we have some high use roads, we have a lot of county roads. So we'll basically put in what we can where it'll function the best. And yeah, that's just kind of the approach that we take.
Very interestingly, I want to mention that the Detroit Lakes boat ramp is a very unique use of pervious pavements as well as biofiltration. Just to emphasize the point that each case is unique, it has to be examined, and with a toolbox of various alternatives, the best of them can be chosen for a particular situation. Surface terrain can affect the place where you put pervious pavements. The depth to your aquifer can also determine if that's the suitable thing, because we're concerned about mounding. We did observe for mounding, we put some piezometers in our main road test cells. Those are things that could determine what would be the best approach. In the Detroit Lakes initiative, we did have pervious pavement that was supposed to filter the drips from boats that were just coming out of the Detroit Lakes. And these drips will go to the pavement through a porous base and into a slanted separating geofabric. And it's slanted into a collection area. And from there, some minimal treatment was done before it was released back into the Detroit Lakes. So these are unique. That was a unique situation where that combination of a filtration system as well as pervious pavement had to be used. So I would say that we have a bigger toolbox now than we had many years ago. We have the pervious pavements, we have pervious concrete, pervious asphalt, which is also an issue to choose between pervious concrete and pervious asphalt. It's an issue. We take many things into consideration. There's the down drain, which is the problem that does occur with asphalt in design. And once you can overcome that, it works very well. The initial thing you observe is some raveling of the surface. And that's for the first year. After that, it's okay. It works very well. So there are many factors. We have larger toolbox, so we can choose which is best for each unique situation. That's what I would say. There's no hard and fast answer.
Great, we have another question up here.
So I'm thinking about a frost heave and a permeable pavement having water underneath the pavement surface. In the roughly 14, 15 years that you've been working with permeable pavements, have you ever seen frost heave? And if you have, I'm wondering what the situation was. If you haven't, I'm wondering why you haven't.
Okay. Let me start with that. I saw frost heave. I wanted to bring a picture here. One of the initiatives we had was the pervious sidewalk. It was the Aggregate Ready-Mix Association that requested that pervious sidewalks be built at Main Road. So we worked with them to build the pervious sidewalks. We said we need to engineer them, remove the topsoil, remove the organic soils, and have the regular pavement design, where pervious design, where you have the pervious base and a pervious subgrade. He said, no, let's see how it works anyhow. Just build it over what you have.
You saw.
And you can guess what the result was. I mean, there was no real, first of all, there was no real, it wasn't a pervious pavement because the base is supposed to be pervious. So the ice lenses formed within the base or just above well, in that case it was subgrade, and went into the previous pavement, and there was a bulge of material that we observed, and it just crumbled gradually. That was an extreme case of heave, an extreme case of the power of potential vertical rise, which is accentuated, especially when this ice lens is built up in a pervious pavement that's not, in a porous pavement that's not pervious. Water is not going through, even though you have a porous matrix. That usually synergistic freeze thaw, and it causes very high pressures to destroy the pavement. Yes, we've seen it at Main Road. I wish I brought the picture. Yeah, and the reason why we don't see it is that we emphasize the communicating voids when we do the mixed design. The voids should not only be, the matrix should not only be porous, it should be pervious. In other words, in the course of construction, there is that excitement of finishing the surface with the roller screed. And if that's done excessively, you lose the porosity at the surface, even though you have a pervious, porous matrix. Then your entire structure is not pervious because water doesn't even enter, even though you have a porous matrix. And so we emphasize that there's no segregation in the void content. It's kind of continuous, and that the void communicating, because that enhances or that minimizes the tortuosity of the design, the tortuosity of the matrix, and enables it to function effectively.
Well, I actually wasn't quite truthful when I mentioned our first pervious concrete was installed in 09. We actually installed our first pervious concrete in 07. But we tend to sweep that one under the rug because it didn't go as well. We had an alleyway that had really poor drainage. Of course, it's the only alley in Shoreview, but we figured, well, we'll try pervious concrete. It was kind of first starting to come into the market, and so we, there wasn't as many techniques as there is now, but the soils were not very conducive for infiltration. They were kind of more clay soil. So we kind of artificially created a sand layer with the drain tile and put the concrete over it. And over time we did have some movement below. I think it was a combination of a bunch of different things. The surface probably didn't get finished probably as well as like our surface in 09 probably didn't help. But having the soils on the side, having a lot of impervious surface very close to it with the garages and so forth. I think it was just the combination of all those items plus a soil that didn't drain very well, and we were reliant on the drain tile to do that. So we did see some freeze thaw effect on that and some heaving. And we actually, this last summer, we removed the pervious concrete because it had degraded to a point where it wasn't really working. So it can occur, but again, I think it's like we talked before, different situations, call for different solutions. And for us, we probably wouldn't put a pervious concrete in an area where you didn't have infiltration type soils, at least so.
We haven't seen any heaving, but we've also, again, kind of put it in these tougher areas where we ended up putting in basically additional rock. So I think in one of our areas we have, 4 or 5 feet of rock, drain tile. So we haven't seen anything, probably because we have just, we wanted to spend the booklet, our entire budget on rock. So we just kept filling. So that worked out well. At least in the regards of heaving. Yeah, the only issue that we've actually seen is just that little bit of slumping or whatever that's happening. That's just happened in a couple of years at Falcon Heights. Just basically between the going from porous to the actual typical. But otherwise, yeah, like over winter, our pavements have held up quite well.
I've never seen any heaving in 10 years. I've never seen any major structural failures with PICP. With pervious concrete, there's not a lot, And so I have seen some examples of spalling and raveling, but again, often it goes back to the mix design and inexperience, general inexperience with, placing concrete and pouring it correctly, which then leads to the legacy issues down the road. So
I think that construction piece for the asphalt and the concrete is pretty critical.
So I have a question about funding, and part of the question is not fair to ask you folks, but of course I'm going to ask it anyway. But there are some folks here, very capable and knowledgeable staff from the PCA, who might be able to answer. Are there special funding sources that are available for porous pavement projects? And then the second part of the question is, if we can substantiate a claim that putting in porous paving helps cities make progress toward meeting TMDL wastewater allocations, would that make additional, particularly state funding sources, available to cities that wanted to do porous pavement projects?
Well, funding wise, I mean, most of our funding comes, just internally through the Stormwater Utility Fund. Thanks for paying into that, Randy. Yes, thank you. And otherwise, Roseville's pretty lucky. We have 3 watershed districts that are very progressive. They really want to do, take part in water quality projects, drainage, flooding. So we typically get some kind of funding from them, whether it's, 20, 50, even up to like $100,000 in some cases. So that's always been probably the one that we go to the most, just because, they're very local, they're very easy to work with. We've always looked at like Clean Water Fund. We would love it if the PCA started to do, open up some kind of grants for looking at, how this could help maybe with chloride reduction, water quality, things like that. So, we'd be very open to discussing that with them.
Yeah, agreed. I mean, again, just like Ryan mentioned, ours is usually internal funding. We have, again, had some assistance from the watersheds. Typically, that's usually where we're looking. But I believe a lot of that money does come down from other sources. So there is some. But yeah, I think that if there was funding made available, I think that is one of the biggest things cities will have to overcome, is that initial cost. And even if you mention that, well, we're replacing 2 systems with 1 system, and there's this and there's that, councils sometimes just have a hard time. Well, we all do, with that initial cost. And if there was some grant money available, I do believe that there would be cities more willing if they could look at it more as a 1-to-1 ratio cost to what would normally be going in. Yep.
Another question here.
Have you all developed any differing snow removal, ice control practices, maybe that differ from traditional pavements, and that are optimal for these kind of pavements?
Yeah, from our aspect, and I don't know if it's just more the neighborhoods that we're putting it in as compared to the fact that it's a permeable pavement, but typically we are plowing with a one-ton vehicle. We haven't been using the big, plows that you tend to use. I don't know how that would be different. We are going to be, as I mentioned, putting in some permeable block paver for a road project next year that's actually on a municipal state aid roadway. So it's a main thoroughfare, which we are going to be using the larger normal kind of plow trucks on, and it will have a little different maintenance as far as salting and stuff than some of our more local roads. So that will be kind of an interesting study for us on how we do get through that. But as far as the other parts of it, it hasn't really changed much. If we get one of those icy rain events and we feel it's a safety issue, we will be putting down salt. Now we do use a brine solution, so not the pebble type, and we've been able to try to reduce that. But typically, no, we treat it about the same. We try not to salt it if possible, but sometimes you just have to.
Same. Well said, Tom.
Thanks. Thanks.
Any other responses to that question? No? We have one more question up front here, and then we'll move to our closing.
Actually, two questions, if I could, Andy. The first one is I was teaching a course last week, and in the course materials, it recommended scarifying the subgrade. And that has always seemed to make a lot of sense to me until all of a sudden I started hearing pavement engineers saying, no, we're designing this for the structural of the compacted subgrade. That seemed to be left kind of in the lurch at the end of the day. What are the thoughts of this group on scarification and loosening up the subgrade versus a compact subgrade on a porous pavement?
So far, what we've done is we have continued to scarify it underneath. We don't have any kind of a fabric. What we were kind of going for is once it's all scarified, once we start getting our rock on top, you know, we go through in lifts and then we start compacting it. So what we thought is that, you know, all we're trying to do is we're trying to get rid of that, you know, basically rock soil interface, get it just so it's a little bit more intermingled. So hopefully we can promote some more. And then basically, you know, all we found is that we're driving some of that rock into the subgrade, which just kind of helped break up, you know, just having one clean cut to a rock. So yeah, it's like we haven't seen any issues with it. And we did a couple projects, even like with our doing an underground, we did it the same way and we haven't had any issues with it. So going forward, you know, we'll probably continue to do it that way. But at the same point in time, yeah, it's like we haven't, you know, done it on a really high use road, you know, a county road. So it's like these are all kind of local collector streets, and yeah, we haven't seen any issues with it.
Yeah, agreed. I mean, you know, usually we have at least a foot or more of rock. I don't know, Ryan, is that pretty typical with you? Sometimes we've got up to 2 or 3 feet of rock. Yeah. So, you know, and once you start getting that amount of rock structure, you can drive a steel wheel roller on it and it doesn't really deflect. So it sets up really well. And I know at least the block that we've been going with, the manufacturer has now suggested going ahead and using a kind of a pavement fabric right over the kind of the choker course rock or your leveling rock. And again, it's I think it's just an attempt to make sure that load gets spread out so it doesn't kind of set up on one block or another block during like maybe a turning movement or something. But we actually haven't seen any like noticeable settlement in different areas. What we just tend to see the thing do is the whole pavement system tends to move together. You know, it kind of, you know, raises up a little bit in the winter and settles back down a little bit in the spring. And over a couple of years, it settles in and locks tight, and just haven't had any problems with that. So.
I just want to mention that just like every regular pavement, there must be soil investigation. And the soil investigation would tell us if what we have there is an over-consolidated deposit. I mean, that might determine if you need to disc it or loosen it a little bit. But at the end of the day, you need a compacted, at least a foot or two of that subgrade will probably need to be compacted. But at the same time, you want to maintain the hydraulic conductivity that's required for it to function as part of the previous pavement. So soil investigation will lead to what is required. If it's probably because of silt, when you want to look at if it's a suitable place to have the previous pavement in the first place. You know, we're looking for granular subgrades to build the previous pavement.
Yeah, the experiences I've had, people are very cautious about idea of scarifying because of, you know, structural concerns. I'd love to try it, but I think it depends on what the situation is. Like if it's a walkway and you have no vehicle traffic, why not? Yeah, but do you do that on a parking lot? Do you do that on a local road? I don't think so. And you have to think about, yeah, is exfiltration really the goal? You know, the experience we've had, that parking lot in St. Catharines, which was zero exfiltration, we still lost 15% of the water. just from wetting that aggregate and it ultimately evaporating. You know, we still shaved peak flows down by like 80 to 90%. So you're still getting those water quantity functions even without without exfiltration.
All right, well, we're getting close to our time, so I'm going to wrap up with a final question for each of our panelists. What I'd like to do is ask for your advice to our audience for practitioners. So based on your experiences with permeable pavements in cold climates, what would you recommend that we do and continue to do? What would you recommend that we maybe avoid so we don't make mistakes that we've seen in the past? So maybe we'll start again down in the end with Tom. Thank you.
Thanks. Yeah, right. Kind of take some cues from what everybody else said. You know, I think just to kind of go on the points that we've already mentioned, that, you know, this is one item that you can use. There are places where it'll work better, where it won't work as well. Just look at it as something that, you know, can solve a problem that you're having. And again, you know, look at the environment it's going to be in. You know, maybe it wouldn't be the best place if you've got a slope and you know you're going to have to be icing that, you know, periodically throughout the winter, or, you know, on a curved area. Maybe you can go with a different type of pavement there and then make up with it somewhere else, or combinations of things. Maintenance is the key. You know, if it's clogged and it's not allowing water to go down, it's not doing what it's supposed to. So if you start on it right away, it's way easier to keep it clean from the get-go than to try to come back and get it back to its previous part. And as Bernard said, it's not like you have, you know, again, depending on your situation, you may have to sweep more, but typically, you know, twice a year, and that should be enough to clean. But, you know, we've been really happy with it. You know, we were a little nervous the first year we did it, the first time we did it, then a little nervous when we tried the paver block, but it's worked really well. As Ryan mentioned, you know, we had situations too where we had people on the lake. You know, it always seems like on lake lots, you have one high house and one low house down by the lake, and the poor person by the lake with all the water. And we've had scenarios where people were like, oh, in rainstorms, I had water running down my driveway that looked like a river. And the permeable pavement came up, and they haven't had an issue since. And so it does solve problems. It does work well. Again, you just need to make sure it's put in the right application and maintain it.
Well, we're at a particular point in the learning process right now. And I believe over the years, expertise has been built. There is help. We don't really use pervious pavements for our interstate or for the US highways or the Minnesota highways. I'm talking about the MN highways, part of the federal highway system. But for the locals, even if it's for an implementation project, you have the local road research board. You can approach them. They will work with you and do a deployment project if you want to deploy a particular aspect of what Jenn talked about today that's interesting to the locals. And also, pervious pavements are not just an excuse for, let's say, a honeycomb concrete or a honeycomb asphalt. It's a different animal altogether. So there is help. There are people who have developed expertise. Synergy, which we developed working with the Aggregate Ready Mix Association of Minnesota, the Concrete Paving Association of Minnesota, MnDOT, Local Road Research Board, and the University of Minnesota. It was Professor Kazanovich and Mary Vancouver, who at that period also did some good work with us on pervious pavements. And that kind of synergy really helped build the body of knowledge we have today. So there are experts that can be approached. Don't just plunge into a pervious pavement because it has become popular. Still talk with us, talk with MnDOT, talk with the experts, and there is help. That's what I would like to say. Thank you.
All right, I don't want to reiterate everything Tom said. So while Tom got to go first and then say that he had to think everything up, you know, he put it very well. It's you know, don't be afraid to use it. You know, not that I want to sign Tom up, but you know, you're more than welcome to give me a call. Give Tom a call too. If you're looking at these local projects, you're looking at, you know, what can be done. If it, you know, it's feel free to shoot stuff off of us. You know, we've been doing this for a while now, and Roseville will continue to do it. So will Falcon Heights, and yeah, we're going to keep incorporating it where we can. And yeah, it's like the big take home is, you know, just, you know, maintain it, you know, get out there, sweep it, get it backed out. That's been, you know, kind of the biggest fear from our streets department. But now that they're kind of in the routine, you know, they see that if they go out there, they sweep it a couple times a year, they can keep it open. You know, it's something that they can handle, and it's just, you know, something they do now. So, you know, the fear of change is real. Roseville's gotten past it. Well, most of it. But yeah, it's like, we'll continue to do it.
Great.
Well, I think I would say one of the things that I've taken away from this study is we really just started to scratch the surface in terms of the research work that needs to be done to develop really optimized best management practices for winter for these pavements. You know, this is just one permeable pavement. We still have pervious concrete and porous asphalt to address, which will behave differently, have different requirements. And as I talked about in my presentation, like there's a huge plethora of products, and trying to figure out, okay, how do we pick the right ones with the ultimate goals in mind of safety, you know, first and foremost, and then reducing our environmental impacts of our winter stormwater. So I know you guys invest a lot in research down here. I really hope that there's been ideas come out of this, but the other thing then, even with the research that we have, the next step is, you know, permeable pavements, one of its primary applications is going to be parking lots, which are private property. Private property owners are not going to implement, you know, change in practices unless they have some confidence that they're implementing things that are deemed safe and aren't going to be, you know, protect them from liability. So these best management practices need to be adopted or promoted at the municipal or state level, you know, saying this is what we want you to do, and we've done the research to show that this is not going to put people at risk. I think that really is sort of the next, you know, the next thing to do. And guidelines, you know, like the person who's out there at 3 a.m, they just tell me if the temperature is this and the precipitation is this, what do I put down? So that's kind of like the tools then for the actual operators. Is the next step too that is also needed.
Great, that's wonderful. So with that, we will close our panel. Please help me in thanking our panelists.